Hi everyone, I am your common techie. This is day 4 of my DSA Growth Series where I solve LeetCode problems daily. So today's problem is related to binary search. So this is kind of a topic under a problem. So what here we are given is we are given an array, uh, a sorted array, either in ascending order and descending, but in this question it's in ascending order, and we have also given a target. So what do we need to find is we need to find the index of the target value. So for example, if like in this array, uh, I have written this array here along with their indexes. So what we need to find, our target is 9, so we need to find the index of that particular target. So that is 4. If it's not there, we should return -1 here. So one approach is like we can start from this element, we can go one step forward every time, and we can check if this element is equal to our target. No, then we can proceed to next element. We'll check if this is equal to our target, then no, then we'll go to next. If this is equal to no, if we'll go to next. If this is equal to no, then we'll go to next, and if this is equal to, we'll just return this index of value of that. So but this here is not a very optimal solution. This gives us a time complexity of about O of n, and as we can see, it is clearly mentioned we need to do it in O of log n. So one thing, just a small trick we can, I would like to tell you is like, if we are given a sorted array, if anytime we are given a sorted array, whether it's in ascending or descending, please have a first thought of doing it with binary search. Just try if binary search can be used in that problem or not. So yeah, so here also, since we are given our array is in ascending order, so we can use the binary search. So small explanation of what binary search is. So basic algorithm of binary search is, suppose we are given an array, we have in that array we have a start value, along with we have an end value. So with the help of this start and end value, we find a middle value. So for example, in this, and uh, okay, I'll just complete the flow first. So once we get the start and the end value, we find the mid value with that, and after we check if that mid value is equal to target uh, or not. If it is equal to target, well and good, we can return that index value, or yeah, that value. If it's not, we'll check if the mid is greater than target or less than target. If it is greater than target, then basically it means that uh, the our solution would be lying in the first half of the uh, array. Or else, if it's smaller than the target, then our answer would be lying in the second half of the array. So accordingly, we said change the end value of the uh, array. For example, I'll just take if it's a value less than our middle value. So suppose, let's consider our middle value is 5 and we need to find 0 here. So from these two ends, we get the middle value as 5. After that, we check if middle value is greater than 0 or not. Since it's greater than 0, it is very obvious, since it is a sorted array, that our solution will be lying in this part. So we move our end from this point to this our mid. So then we'll repeat the process again, and we'll again check if it is we'll again fetch the mid, we'll check, and here our mid will be coming around 0. So mid, we'll check if mid is equal to our target or not. If it is equal, well and good, we'll just return this. So I'll just try to write a code for this. We'll just keep a start value equal to 0 for now. We'll also keep an end value which is equal to our array length minus 1. We'll just start a normal while loop, and the condition here would be start would be less than equal to end. So at first point, as we told, we need to calculate the mid here. So one point to note here is we can also calculate the mid by simply doing start plus end by 2. Uh, but since in very large arrays where start and end values are too great, very high, so there it causes some issues. So it's better to do calculate the mid this way, and we'll continue. We'll first check if our mid value is equal to target or not. If it's true, we can simply return the value of mid or the index. If it's not, we'll check if our target is less than the mid value of the array. If it's less, so we already know if it's less, so it will lie in the first half, so we need to move the end of the array. So end would be mid minus 1. Else, we need to move the start of the array. And if any of this return is not matched, that means we have not found our element. So if we have not found our element, we need to return minus 1. We'll just quickly try to run this problem. Small typo here. Yeah, as you can see all the test case paths, we'll try to submit this solution. Yes, so as you can see, this is what binary search is all about. It's very simple. Just try to write it for 3 to 4 times, and you'll just try to understand where it will be used. Yeah, and please remember the tip. If it's a sorted array, please try at least once for binary search. So yeah, that's all from my side for today. Thank you. Have a great day.